Hello, it's KP to Math G. We are, it's the day after Christmas, and my Christmas is not quite done. I've got a trip to make, and let's see, I don't know if you can see this picture here, but that's a picture of me holding my grandson, and my wife and I are going to see our grandson, and of course, son and daughter-in-law, and we're looking forward to that. But although it is a 6.5 hour trip, which means really for us it's going to be an 8 hour trip, because we're going to stop, and at our age you got to stop frequently and go to the bathroom. Okay. My wife probably wouldn't want me to say that, but anyway, it's just a lot of fun here. I'm just having fun with it. Okay, let's get to business. We are integrating by substitution, and I didn't put the part up here, part 4, part 5, so either one of those two. This is a special case, and I did one in the last video that I did, and I'm going to do another one because this is important that we understand this. And the question is, when do we do substitution? Well, two reasons that we do substitution is if this exponent happened to be a 2, this would be very nice right here. So I mean, if the exponent inside under the radical is, or whatever, if it had been e to this right here, okay, if I had this right here, okay, I still would let u be that, okay. Whatever is either raised to this exponent or underneath a radical like this, and in other situations you want to do that, but we don't have a square here. That's what makes this case very special. But the exponents are the same, and we can do something about that. Okay, so let's get started. We're going to let u be what's inside here. Okay, so let's put a let statement up here. Let u be equal to 2x plus 1. Naturally, we do du. Alright, we are going to do that. Du, u, and du. Do that immediately. Du is equal to 2 dx. Because when we take the derivative of 2x, that's just 2. And then, of course, the dx on the end. Okay? But we don't have an x dx. So we're going to get to that in just a moment. But let's go ahead and remember how we do this. We multiply by 1/2. Let's take care of this part of it first. 1/2 du. So 1/2 du is equal to dx. And so let's see those divide out. See what I'm talking about? So take care of this u du right off the bat. You got to figure out what u is. U is going to be what's underneath this radical. I know we don't have an x dx. So now the part 2 of this, well, let's put the 1/2 on the outside here. We have that 1/2. And so far what we have here is u. Now remember, this is the square root of u, okay? And we haven't done anything with that x, have we? But we still have the dx right here, okay? Du, I'm sorry, du. We're putting everything in terms of u right now. We still haven't taken care of this. By the way, incidentally, I can rewrite the square root of u is equal to u to the 1/2. Keep in mind this index is 2, the exponent is 1, u to the 1/2. So let's rewrite this instead of making another line here. Okay, I've got that part so far. I'm just putting down the part that I have. I still need to deal with this, otherwise we can just forget about trying to integrate this. So part one of your this solving involves, well, let u be what's underneath this radical. Du is 2dx, and of course 1/2 du is dx. So take care of that. Check that off. All right. Second thing, maybe you want to rewrite u. The square root of u is u to the 1/2. Now, of course, we have u is equal to 2x plus 1. Let's go back to that, because we need to figure out what x is. Well, to figure out x is, what do you think we need to do from this problem right here? Yeah, that's right. Solve for x. So let's do that. So minus 1. So u minus 1 is equal to 2x. And in solving for x, I'm going to have divide by 2. And this is u minus 1 over 2 is equal to x. And that is exactly what I want. So I've already checked this part off. I got this done. I got this much done here. And I'm about to figure out what x is right here. Well, it is u minus 1 over 2. And I like to say this, if I have something like, say maybe that in particular, like a over b, there's a rule that says a over b is actually 1 over b times a. So really what I want to do is, this is actually understood 1 here. So this is actually a 1/2 times u minus 1 is equal to x. So I have another 1/2, don't I? All right. So this is what I have. I've got u minus 1, 1/2 times u minus 1. So I'm going to put this down here. 1/2 times u minus 1. Now still bring down the u to the 1/2 du, and that is really the idea behind this special problem here. This is really where I want to get right here. Okay? So back up just a little bit. This is u substitution. You have the same exponents here. Let u be this. We've already talked about this. Du is 2dx, but 1/2 du is dx. So there is this. So I rewrote this. U to the 1/2. Okay? Du. Already did that. I took care of that part there. Then I said, well, I need to solve for x. So that's what you need to do here. So your next thing is solve for x, and we did that. We got x is equal to 1/2 u minus 1. Somebody may ask, well, KP Math G, can you put that 1/2 out there too with that other 1/2? Of course you can. So we have, what we have here is 1/2 times 1/2. Now u minus 1 u times u to the 1/2 du. This is really, you know, if, like I say again, if you can get down to this part, voila, you got it. You understand it. Now, let's erase all these goodies because we need some room. And let me let you be that. Leave that part up there. I might need to come back to that later. I don't want to forget what I let you be. Of course, I can always go back to this and see what I let you be, but that's okay. You know what, guys and girls, we can. Do I need to move my? Oh, my wife just got up and she needs to. I've got one of the legs in the bathroom door, and I think she needs to use the restroom. So, okay, hon, you can shut that door. I just want to make sure I'm still good here. Yes, I am. Okay. Sorry about that. I was trying to do this while my wife was sleeping, but she probably heard my big mouth speak and loud mouth, and that probably woke her up. So, no, I'm just kidding. I don't know, I may not be. Alright, so look here. let's take this off to the side. I've got u minus 1 times u to the 1/2. I think I can fix this up a little bit. Isn't this to the 1 power? And can I not write this as an expression of something over 2? Well, I know that u 2 over 2, that's the same thing as u to the first, minus 1. Now, do that. Now, learn to do that. If this had been a 1/3, this would have been 3 over 3. If it's been a 1/4, I would have done 4 over 4. Okay, so 2 over 2. So here we are. We're going to multiply this. U to the 2 over 2 times u to the 1/2. You ought to be able to do that in your head. And then minus 1 times u to the 1/2 is just u to the 1/2. What's this? That's right. U to the 2 plus 1 is 3/2. And then you got u to the 1/2. So we're rewriting all of this right here. I'm going to go ahead and make this 1/4 here. Alright, so let's erase what I just did here. Okay, I'll just erase this. Okay. So I'm putting all this now in place of that. So here we go. 1/4. Now u to the 3/2 minus u to the 1/2 du. Okay, we are at that crucial point. Just make sure u to the 3/2 minus u to the 1/2. That's really what you want to accomplish here. Okay, is to get down to this, because I know that you can, well, I believe you can, you know how to integrate this, right? Okay, so that's not the issue. KP, I know how to integrate from here. We're going to finish the problem, but in case there may be somebody who still struggles with this. Okay, now that I have all this, I multiplied this and got this. All I did was distribute my 1/2. And recall, this is the 2/2 here. 2 over 2. Alright? So, u to the 3/2 minus u to the 1/2. Okay, let's keep going. Still got the 1/4 here. Now we're integrating. We don't need this anymore. Alright, so we got u. Now, add 1 to 3/2. So plus, again, this is how I add 1 to 3/2, 2/2. So this is u to the 3 plus 2 is 5/2. And remember, I'm going to flip this over to 2/5. Usually you put a 5/2 underneath here, right? Okay. Well, just flip it over and you got your 2/5. And that's just kind of doing it the quicker way. That's a quicker way of doing this. Alright, let's take care of this one. U to the 1/2. So u to the 1/2, I'm going to add 1 to that. That's 2/2. So, excuse me, this is u to the 3/2, but I'm going to flip that over and make that 2/3. So now this is 2/3 u to the 3/2. Alright, and now I can put my plus c at the end. Can you include it here? Yeah, but I mean, even if you multiply 1/4 times c, we just use the general c anyway. Okay, now we're almost done because it says substitution, and we substituted u in place of x. So now we need to put x back in place of u. And now we're done, because now this is 1/4 times 2/5. Alright, so u is 2x. I knew I needed that for some reason. Alright, so 2x plus 1 to the 5 halves, coming down with 5 halves. Alright, minus 2/3. Alright, we know 2/3. Alright, now that is, again, 2x plus 1. See that? That is, again, raised to the 3 halves. Okay, plus c. If you want to, you can distribute the 1/4 over both of these. You may ask your teacher or your instructor or your professor if this is okay to leave this like this. They may say yes or no. If it is no, then we got to distribute this, which is actually, okay, so 1/4 times 4/5 is 2 over 20. 2 over 20, which is 1 over 10. Okay, and I actually like to just cross out the 4 and the 2 like that. Okay, 2 goes into 2, 4, 2 goes in 4 2 times, 2 goes into 1 time. 1 times 1 is 1, 2 times 5 is 10. Don't forget you got to multiply 1/4 times this as well. Okay, so this is going to be 2x plus 1 to the 5 halves. Now remember, you are multiplying 1/4 times 2/3, and notice that the 2 and the 4 will divide out again. Alright, so 1 times 1 is 1, 2 times 3 is 6, so minus 1/6. 2x plus 1 to the 3 halves plus c. Alright, now I could write this as the square root like this if I want to, and put a square root here, raise this to the 5th, raise this to the 3rd. So I don't know, again, that depends on your instructor. So what am I saying here? Well, I don't want to have to erase this, but I'm going to. Okay, so we could fix this up one more time just a little bit. Alright, we could say, alright, so we could say this is equal to 1/10. Alright, now just make a square root. A square root of 2x plus 1, and if you want to raise it to the 5th, you may, either inside or outside, it doesn't matter. You can raise it to the 5th. Okay, minus 1/6, square root of 2x plus 1, again raised to the 3rd this time. Okay, your index is 2, that's where your square root comes in right there. Alright, okay, 5 over 2, 3 over 2, there you go. But we don't use the 2 in there, you know, we just write it like that, so there again. Alright, and then plus c, let's not forget that. Okay, either way, I'm going to say either way is good. Some answers show this. I know on the AP exams, some answers just show this. Some answers may go as far as to do this. Okay, and there's actually even more simplifying that we could do, but we're not going to get into that. We just want to get the idea behind this problem right here. Okay, so again, let u be 2x plus 1, du, alright, find du, alright, then solve for x, and then do all that substitution that we did just a while ago. A tough problem, but it's a problem that we do need to learn how to address. Whether you're taking AP calculus or just plain calculus, you need to learn how to address these types of integration. Okay, this is KP, the Math G. Please do not forget, if you will, I've got a few subscribers. I'm hoping for some more. Please click on that subscribe button, and if you will, if you need to make a comment, please do. So you can say, KP the Math G, nice job, or even KP the Math G, this was a good job, but you could have done this better. And I always want to get better. That's my idea, to get better so that you can get better as well. So once again, KP the Math G signing off. Everybody have a wonderful Christmas and New Year season.